Right. This is the second part of the rational functions. But this is the recording is the second part, but this is the third part and the fourth part in this section. So the third part, we talk about x-intercepts and y-intercepts of rational functions. So we do understand when we graph any functions, knowing what these two intercepts is very, very important. Now, of course, including graphing for rational functions, determining x and y intercepts is very important, of course, very helpful for graphing something when the graph go through y-axis and x-axis, what exactly where the point is. All right. So now let's take a look at how can we determine it. It should be very easy. I'm just going to give two examples because A, B, C, D is going to be too tedious. So we just pick C and D to talk about it. All right. So now what is y-intercept? Y-intercept is when x value equals to 0. So in terms of this, when x value equals to 0, so that becomes 0, that becomes 0, that becomes 0. Then, of course, then your y value is 9/2. So then this is your y-intercept, right? 9/2, this is your y-intercept. Now, x-intercept is when y value equals to 0. So then this part now becomes 0. So this part it becomes 0, then that means on both sides of the equation, if we just multiply this whole denominator, then we would leave it just x to the power of 2, subtract 9 equal to 0, because 0 multiplied by that is 0 anyways. So then we ended up with this factored form. So then x will be equals to -3 and +3. So x-intercept is +3 or -3, +3. So then that is our x-intercept. Now this another example. At this time, it doesn't look like a rational function. It looks like a one rational function, subtract another rational function, plus another rational function. But how can we make it just as gx over hx? Well, that is just adding the fractions with a whole number. So there's a fraction, the common denominator, and this is a whole number, it becomes this. Now the common denominator becomes that. Now this one will be multiplied by x minus 1. This one would multiply by x plus 1. Now, very important thing here is to be careful. This is the bracket here. You should always carry on this bracket because this negative is outside here. See this negative? After you open this bracket, not only this x is negative x, this 1 becomes -1 as well. And then, because the 2 have to multiply by the whole common denominator, then that means 2 multiplied by x plus 1, x minus 1. So organize this, simplify it, it becomes 2x squared subtract 4, and then that is the bottom. So in this case, when x equals to 0, x equals to 0, x equals to 0, then we become 4. The y is 4. So this is the y-intercept. On the other hand, if this whole thing equals to 0, means the y equals to 0, and then your x has these two solutions. So then this is a 2 x-intercept. Now our fourth part is more interesting. So this is called the holes in rational functions. That means when you graph a rational function, at some part of your curve or on your graph, you got a hole. The reason why you got a hole, it is because there's no value at that point. So how does that happen? So now take a look at this. So this is a rational function here. for this rational expression, but this whole thing is a rational function. And you realize that the bottom can be factored. When the bottom factored, it becomes x minus 1, x plus 2. So then x plus 2 cancels out. So then your function reduced to this rational function, and then your graph is this. So here, yes, we do have a vertical asymptote because x cannot be 1. So of course, this is our vertical asymptote. But seemed like that our another asymptote, which is x equals to negative 2, does not exist anymore because it canceled out. Nevertheless, x cannot be negative 2 because if x becomes negative 2, you don't have a function here. Therefore, you don't have vertical asymptote, but at this point here, negative 2 here, you have no x value, you have no x value, you have no y value. So a hole is created. Now, let's take a look at the different functions here. So note that whenever you see a rational function, you want to see whether or not the function can be reduced, which means whether or not you can factor the denominator function and to see whether or not you cancel with the top. So in this case, we do know the x minus 3 cancels, so we have a only reduced to 1 over x plus 2. So then you have a vertical asymptote as negative 2, but also the point here, this x minus 3, the x equals to 3, this point is a hole, has to be excluded. Okay. Now this one, interesting, this is reduced to a rational function, right? So it's still curve. This, as a matter of fact, the function reduces to a linear function. So linear function, so then therefore you don't have just a straight line, so you do not have an asymptote, a vertical asymptote. But this function here, still, it cannot, the x has no negative 4 value. So this point is a hole on your graph. Okay. Now this one, well, there's both two brackets are being canceled. So in this one here, you still have this x 1 over x being reduced. So then x equals to 0 is your vertical asymptote. But then again and again, your negative 2 and positive 2, those values do not exist because your x cannot be either negative 2 or positive 2. So then that's two holes are created. All right, so now this concludes 4 parts of this section, which is just introduce you to rational functions. Thank you for watching.